Hi, we're going to look at the AQA GCSE Practice Paper 2 for the higher tier. Like always, it's 80 marks, it's 1 hour and 30 minutes, and the idea is that this one is specially prepared to cover the topics for 2022. Let's get started. First question, circle the decimal that is closest to the value of 39/800. So let's put it into the calculator. And you end up with a decimal, and the decimal comes out to 0.04875. And we have 4 decimals to compare it with. Notice we have 5 decimal places, so it might help you make all of them 5 decimal places. And now you have here 4,000, 5,000, well, it's not really that, but for comparative purposes. And you can see that these two extremes are far away, and it's between these two. If you're not sure, the best thing to do is to take it away. So that minus this, that minus that, that minus that, that minus that. But you should be able to spot that those are far enough away, and it's between these two. In this case, you'll notice we have a difference of 75, or if you want to actually subtract, you can put that in there. So you'd have our answer minus 0.048, and it tells us that basically we are 0.00075 away. We can do the same on this one, 0.049, take away 0.04875. In this case we notice that we are 0.0. If you don't like working in standard form, make sure your calculator is set in the normal mode, but in my case I've got it as a standard form just because I'm quite happy with that. In this case you notice here we have 75, here we have 25, which says that this one is the one that's closest to that fraction. On to part 2, and part 2 is just testing your general knowledge. Which of these numbers is a power of 3? Now hopefully you know your 3 times tables, and you'll notice that 3 times 3 times 3, or 3 to the power of 3, is 27. Okay, but if you don't know that, you can basically in your calculator put 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and you can keep doing it until you get to 3 to the power of 3, and out comes 27. So it's knowing the powers of 3, or the 3 times table. Prime numbers, well obviously here that's divisible by 5, that one's divisible by 9, and 31 is not divisible by anything to get a whole number, so that's your prime number. 32 can be halved, 44 can be halved, and 45 is divisible by 5. You get onto the part C, circle a number that is a factor of 900, and this looks like there's only one answer and there's only one mark, but in fact there are 2 answers, so you get to choose. What they want by a factor is something that you can divide 900 by, so you could say 900 divided by 25, and you notice it comes out as a whole number, so that is a factor, so you could circle 25. If you did 900 divided by 27, you'll notice that you do not get a whole number. Same thing as 900 divided by 31, once again not a whole number. 900 divided by 32, again not a whole number. 900 divided by 44, not a whole number, and then you get to 900 divided by 45, and there are, in fact, that's an answer. So you have 2 choices, 25 and 45 are both factors of 900. You're on to question 3, and question 3 says factorize x squared subtracting x. There's a common term which is x, so we can take x outside. We open our bracket, and here we'd be left with x times x, so this is going to be an x in there, subtracting. Now x times what gives x? Well, times 1. So here we have x times x squared, x times -1 would give me a minus x. Part B, multiply out and simplify. So we're first going to multiply out this part, then we're going to subtract the 8x. So 5x times x is going to be 5x squared. 5x times a -3 is going to be a -15x, and then take away 8x. Okay, just checking, 5 times that is 5x squared, 5 times 3 is 15, it's negative and there's an x, and then we just have, so we've done the multiplying out, or expanding the bracket. Now we're going to simplify it, and there's only one x squared term, so I can keep that as is. but here we have two terms with x to the power of 1. So if we collect those, simplify it, we'll end up with a minus 15 and a minus 8, so we're going to end up with a minus 23. If you're not sure, you can just put it in your calculator. Minus 15 minus 8 will give me a minus or negative 23. Do not forget your x. And there you are, you've got your answer. Brilliant. Question 4 looks like a, sorry, let me just straighten up, a ratio question. And we have that Abby and Judy share some money. Abby gets 25%. Write Abby's share to the ratio of Judy's share as a ratio. Give your answer in its simplest form. So notice we want to have Abby first, and second we're going to have Judy. Abby, Judy. And they tell us that Abby gets 25%. Now the total is 100, so if Abby gets 25, the remainder will go to Judy, and the remainder would be 75. So far we have a ratio, but they want it in its simplest form, so we want to simplify this. And you notice in the 5 times table, so we could divide by 5 to get 5 here, and divide by 5 to end up with 15 here. But you might also spot that here we have 1 lot of 25, and on this side we have 3 lots of 25. Don't worry, if you don't spot that, you can just do the 5 times tables and then see what other common factor and simplify it again. But here we can see that there's a common factor on both Abby and Judy, that's 25. So if I cancel the 25s, I'm left with Abby getting 1 part and Judy getting 3 parts. And that's in its simplest form. Part B tells us that Judy gets £19.50. How much does Abby get? So once again, we're going to take off ratio. And we know from what we worked out that Abby gets 1 part and Judy gets 3 parts. But they tell us that Judy actually gets £19.50. And the question is, what does Abby get? Now this is where you're keeping the ratios. You basically is looking for an equivalent ratio, and you're identifying what's happening to the right hand side, and that's what's going to then happen to the left hand side. So 3 times something equals 19.5. So we're going to work backwards and divide. So we're going to say 19.50 divided by 3 comes out at £6.50. So in this case, so 3 lots of £6.50 gives this. So 1 lot of £6.50 will give us £6.50. Now remember, you're not allowed to use coloured pens in the exam. This is just for me to show you what's happening. You're meant to use a black pen in the exam. So the answer is Judy gets £6.50. Question 5. A biased coin is thrown 250 times. The relative frequency of the heads is worked out after every 50 throws. After 50 throws, the relative frequency was 0.4, and then they had another 50 throws, so now there's a total of 100 throws, and here's the relative frequency, and it just keeps on increasing, and they keep calculating the relative frequency. Circle the best estimate of the probability of heads. Now this is showing us what's happening for heads, and the best estimate of anything in any experiment is an experiment that you've done more times. If you just do an experiment once, it doesn't give you a good picture. If you do it many times, you get a better picture of what's happening. So in this case, the one that has more times happening is 250. So the best relative frequency or estimate for it will be 0.3. So there we are. Excellent. We're on to question number 6. Question number 6 presents us with ABCD as a figure, ABCD, and they tell us it's a trapezium, that they've marked them right angles. They've told us this side is 3 centimeters, that long side there is 10, and this one over here is 9. Work out the lengths of BC. So they want us to work out that length there. Okay? But you'll notice that a trapezium is actually made up of a rectangle and a triangle, yes? And if this is a rectangle, the bottom of the rectangle will be the same as the top. So if I want to work out what BC is, it's working out the same as what that distance there is. Now what else do you notice? You notice that a rectangle, all the all the angles inside the rectangle are right angles, which means that this side is also going to be a right angle. So we now have a right angle triangle we're working with. Why is that important? Because we're looking for this distance. We have a right angle triangle, so Pythagoras hopefully comes to your mind. We have the hypotenuse, which is 10 squared. We're going to subtract the side. Which side? Well, we want to find the blue side, so we want to subtract that side there. But they haven't given me that value. They've said that 9 is all the way from the bottom to the top. But we know that this side is 3, so we also know that that side is 3. So 9 take away 3 will leave me with 6. So this red side is 6 centimeters long. So when I do my calculation, I'm going to use 6 here, square. And because it's a calculator paper, we can do it all in one go. So I have 10 squared, subtract 6 squared, all square rooted. So using a calculator, I'm going to have 10 squared, subtract 6 squared, and we get an answer of 8. And so the side that we're looking for is worth 8 centimeters. Now they've written centimeters, sorry about that, down here, so I don't need to write the centimeters in. But if they didn't, I'd have to include the units. Why did I subtract? Well, the hypotenuse is the longest side, and I'm looking for a shorter side. Question 7. Question 7 shows us a table of some scores for 20 students in a test. These are the scores, 7 up to 10, and the frequency, how many times. So there were 6 students that got a score of 7, and there was 1 student that got a score of 10. Work out the mean score. So to do that, we're going to find the total. And the total we can work out by saying we had 7 lots of 6. Okay, 7 lots of 6, 42. 8 lots of 9, well obviously you can do this in your head, but it is a calculator paper, so if you have any doubts, just put it in your calculator and work it out. Like for example, 9 times 4 is going to be 36, but you can just put it in just to check, 36. And 1 times 10, well we all know what 1 times 10 is. Okay, so those are my totals, so I'm going to add those together to work out my total. Once again, you can put it into your calculator, or if you prefer to do it by hand, that's fine. So it comes out to 160 when I add those together. So to work out the mean is the total scores of all the students put together divided by the total number of students. How many students do we have? 20, or if we add the frequency, we get 20. So when you do that, you're going to end up with 8. 160 divided by 20 gives us a score of 8. So it says work out the mean score. The mean score was 8. Beautiful. We're on to question number 8. And question number 8 says the diagram shows a quadrilateral. There you are. We have 4 sides, as a quadrilateral has, and each of the angles is described by an expression. It says work out the value of x. Well, what we know is a quadrilateral, the total of all the angles will add up to 360 degrees. So if we add all these together, it will give us 360. So we have 2x plus another 2x is 4x, plus another 2x is 6x, plus another x there, 7x. And then we have 30, take away 10 is 20, 20 plus 25 is 45. You notice we've written an equation where we have added all the expressions, and we said they're equal to 360. So now we're solving this equation. And to do that, we obviously just do the opposite to both sides. So I want to get rid of that 45. So I'm going to take away 45 from that side, which cancels here. So I'm left with a 7x on this side equals 360, take away 45, leaves us with 315. And once again, I want to divide by 7 so that these cancel to leave me with my x, which means that I also have to divide this side by 7, keeping it balanced. So we have 315 divided by 7, the answer comes out to 45. So the value of x, which is what they're asking for, is worth 45 degrees, and I've got the word degrees down here, so I don't have to write it. Okay, nice. Let's have a look at question number 9. Question number 9 has a pie chart. It shows some information. the votes for 3 candidates. They've told us it's not drawn accurately, but they have presented that Mr. Smith had 64 degrees worth of this pie chart, and the rest was divided between Mrs. Wood and Mrs. Patel. The angle for Mrs. Wood would be 24 degrees more than the angle for Mr. Patel. So whatever she had, she had another 24 degrees. In total, there were 5,220 votes in total. Work out how many votes Mrs. Patel had. Now, there's many ways of doing this. The way I'm going to do it is using algebra, but you don't have to do that. You can also use a little bit of common sense. What we have here is I'm going to work out what is the angle of Mrs. Patel. And I'm going to call hers x, the unknown. Okay? And we know that Mrs. Wood is the same as Mrs. Patel, x, but has another 24 degrees on top of that. Now the full circle is worth 360 degrees, so I can write this as one equation because I can collect all those expressions, and I have x plus another x, which would give me 2x. And I have 24 plus 64, so 64 plus 24 leaves us with 88. And all of that is, so what I'm doing at the moment is just looking at the angles, okay, to find out what size angle Mrs. Patel has. So when we solve this one, we're going to subtract, like we did before, we're going to subtract 88 from both sides. Sorry, 88 from both sides. When we do that, that cancels this side, so we're going to end up with a 2x. 360 take away 88 leaves us with 272, and then we're going to divide this side by 2 and that side by 2 to keep it balanced, so the 2 cancel to just give me what the x is worth, and 272 divided by 2 is 136. So that's the angle that Mrs. Patel has. Her angle is equal to 136. Sorry. Okay. Now they didn't ask us what angle, they asked us how many votes did she get. So this is a proportion, and the proportion of the angles that she had was 136 out of a total of 360. So that's the fraction of the angles that she has. We're going to multiply it by the total, which is 5,220. Obviously I could write it down here, but so that you can see it, I've done it up there. So we have 136 divided by 360. Sorry, let's try again. 136 divided by 360, all multiplied by 5,220. And that tells us that she will get 1,972 votes. So down here I can write it 1,972 votes. Now, if you don't want to use algebra for this bit, you could just use logic. You could say 360 take away 64, then take away 24, and then split it between 2. So there are different ways of doing it. Question 10. So question 10 tells us that 1,000 centimeters cubed is the same as 1 litre, and they tell us that a tank contains 45,000 cubic centimeters of water. The tank leaks at 0.75 litres every minute. How long does a tank take to empty? Okay, so we're going to have to work in litres and minutes, and at the moment we have a tank and it's in centimeters cubed, so we're going to have to change that into litres, and that nicely helps us here. So 1,000 centimeters cubed is 1 litre, so I'm going to find out how many thousands are in here. So what I'm going to do is I'm going to say 45,000 divided by 1,000 to find out how many litres, and that cancels very nicely to leave us with 45 litres. Okay, now that's the size of the tank, and every minute that amount of litres is lost. So we're going to take the amount of litres we have, and we're going to divide it by how much time, and by how much is lost every minute. Okay, so 45 divided by 0.75 presents us with 60 minutes. Okay, why minutes? Because we work in minutes. Okay, so it comes out minutes. Now in this case, they've just say how long. So the answer for this one could be 60 minutes. Make sure you put your units in. Or if you wanted to, you could have said 1 hour. But you notice why it's important to use the units so they know what you're talking about. So your answer could be 60 minutes or it could be 1 hour. How we're doing. Let's see. Question 11. The first 4 triangular numbers are shown. 1, 3, 6 and 10. Write down the next triangular number. Now you might know them, in which case you can say the answer already, but if not, it's just a reminder of what triangular numbers are. So we have, there's 1, 2, 3, and each time we just add another dot, and that's how I call triangular numbers. Yes, so the first time you have 1, the next time you add the 2 rows, so you get 3, the next time you add all 3 rows, so you get 6, the next time you add all the next rows, so you're going to get 10, and the next one will be 10 plus another 5, which will give you 15. And obviously the pattern would continue. Question 12a, circle the value of the reciprocal of 0.2. Now that's testing that you remember what reciprocal means. Reciprocal means that whatever value you have, you're raising it to the power of -1. You have a button for that on the calculator. Here it is. So in my case, I'm going to put 0.2 reciprocal, press equals, and it comes out to 5. So there we are. There's our answer. Okay. Write down the value of 8.5 to the power of 0. Now that's, you should know by now, it will come out as 1, but if you don't, put it in your calculator. And you can see it comes out to 1. No excuses, you have a calculator, use it. Question 13, work out the value of 81 to the power of -1/4. Once again, if you know your rules and you can do it, you can actually do it yourself, but it's a calculator one, so let's not beat around the bush. Put the power in, -1/4. This is where knowing your calculator really pays off, because you notice the value comes out as a third. They haven't asked us to write it as a decimal, so I'm going to leave it as a fraction. Okay, good. Question 14. They tell us that there's 2,476 adults watch a cricket match. The ratio of men to women is 3 to 1. How many more men than women watch the match? This has 3 marks to it, and it's one of those questions that has, again, different ways of doing it. Whichever way you do, just make sure you get the same answer as I do at the end. Okay, so one way is to identify that we had men and women 3 to 1, and they're telling us that in total we had that many, and so the standard thing is to find out how many parts there are. And here we can say, oh, there's 4 parts. Yeah, by adding them together, there are 4 parts to this ratio. And we say, well, there's a total of 2,476, and we're going to split it into the 4 parts to see how much each part is worth. 2,476 divided by 4. So each part is worth 619. Now we could work out how many women there are by saying 1 times 619, and we could say men 3 times 619, and then we could subtract 1 from the other, and that would give us an answer. But in my case, what I'm going to say is how many more men than women? Well, notice that here we have 3 parts and here we have 1 part. So there are 2 parts more in the men than in the women. So in other words, we want to find out what 2 parts is, and 2 parts is worth 2 lots of 619. So times by 2, and so the answer for this one is 1,238. So whichever method you use, you should be getting that answer. Okay, where are we? We're on to question 15, and it says, in this question use, and they provide us with 2 bits of information, that 1 pound is worth 0.4536 kilograms, and that 1 inch is 2.54 centimeters. The pressure of a basketball is 7.5 pounds per square inch. Work out the pressure in grams per square centimeter. Okay, so things to notice. Here we have pounds, and they want the answer in grams, And here we work in square inches and they want it in square centimeters. So we're going to have to change that pound into grams. And to help us, we have that 1 pound is worth so many kilograms. So I'm going to take that 7.5 pounds. I'm going to multiply it because every pound is worth that. So I'm going to multiply it by this to work out how many kilograms we get. So 7.5 times by 0.4536. Make sure that it is actually correct what I've typed in. It comes out to 3.402, and that's how many kilograms 7.5 pounds is worth. However, we don't want kilograms, we want grams. So to change it to grams, I'm going to have to multiply it by 1,000. So if I multiply this by 1,000, I'll end up with 3,402 grams. Excellent. So we've worked out that bit there. We've done the grams, okay? And then we're going to have to divide it by square centimeters. But at the moment, we're not in square centimeters. We've done the pounds, but we're in square inches. Now, a square inch, basically, you have to remember that it basically tells us that we have 1 inch in this direction and 1 inch in that direction. And when you multiply it together, you'll end up with 1 square inch. Okay? So if we were to change that, 1 inch is the same as 2.54 centimeters. So this here would be worth 2.54 centimeters. And this one would be worth 2.54 centimeters because 1 inch is the same as 2.54. So if we want to work out the area of this, we'd have to multiply these together. Okay, so 1 square inch is the same, identical to 2.54 times 2.54 to get our answer. 2.54, you can square it because that's the word squared comes from. It comes out to 6.4516, and that's going to be centimeters squared. Okay, so we have our square inches changed to square centimeters, and the final bit is to do grams per, which means divide by square centimeters. So we have our grams, and our grams were 3,402 divided by the square centimeters, which is going to be 6.4516. Okay, so let's do that. 3,402 divided by 6.4516 gives us an answer of 527.3110546. Okay. Now, they haven't specified how many decimal places they want or how many significant figures, so in this case I'd probably keep it all there. It's not very nice to copy all, or you could round it a little bit, considering here we have like 4 decimal places, 2 decimal places. You could do a similar type of thing, but I'm just going to write it all down because it only takes a little while to write and they haven't specified what they wanted, so I'm just going to write it all down. There you are. Okay. Good. So now we're going to move on to question 16. Question 16 says x and y are integers. Remember, that's the same as whole numbers. And x satisfies this inequality. In other words, it's bigger than -5, but it's smaller or equal to 3. And y is 2, any number between 2 and 7. Okay. Work out the largest possible value of x squared plus y squared. Now, for this to be big, because they want the largest one, we need x to be large and y to be large. So we want the biggest numbers possible. But there's a little catch, because they're squares, and so even though we're working with negative numbers, when you square a negative number, it actually turns into a positive one. For example, if I do -5 squared, sorry, let me close the bracket, you'll notice we get 25 because negative times negative gives a positive. So when we're considering the values of x, x is allowed to be -4, -3, all the way up to 3. And when you're considering y, y can be anything between 2, 3, all the way up until it gets to 7. So when I say I want the largest value here, you think, oh, largest, oh, we'll use positives. But actually, 4, when I square 4, that's going to give me a bigger value than the 3 squared. So I'm going to choose for the x squared, negative 4 squared, plus, and for the y, well, the biggest value for y is 7, so I'm going to take 7, I'm going to square that. So we're going to have, now remember to put your brackets in, 4 squared, which is going to be 16, plus 7 squared, which will be 42, and 42 plus 16 will be 65, and that's the biggest value we can have. Okay, good. Just making sure I haven't made a mistake. No, that's looking good. Okie dokie, let's move on. Sorry, it was 49, wasn't it, when I said that? That's what I was just thinking about. Never mind. The value was correct on the calculator. Just what I said was wrong. I said 7 squared is 42. It actually isn't. It's 49. Okay, here we have 17. Question 17 presents us with the speed of 15 vehicles, and they were measured as they were going along a road. And there were 2 cars that were travelling up to 40 miles per hour, 11 cars that were travelling slightly higher than 40 but low, up to 60, etc., until we got to 4 cars that were travelling with a speed that was greater than 90 miles per hour. Every driver travelling at more than 70 miles per hour is fined £60. On average, there are 8,400 drivers using the road each day. Estimate the total number of money raised from the fine. So we need to find out what proportion of the drivers are going over 70 miles per hour. And it's going to be an estimate because obviously these are ranges, they're group data, so we're not exactly sure where these various drivers were at. We just know they're in those groups. And using that then as a way of estimating how many of the total drivers in one day would be fined. So we're looking at things that are over 70 miles per hour. So this is over 70 miles per hour. This one's definitely over 75 because see, it's over 75, so that counts. But this group here, 24 of those are between 60 and 75. And if you imagine you're going from 60 all the way up to 75, okay, you're jumping up in 5, couldn't we? We'll go 60, 65, 70, 75. So what we're going to do is we're going to estimate that those 24 people are split evenly between the whole group. So 24 divided by 3 is 8, so we're getting 8 people there, 8 people there, 8 people there. So there were 8 people between 60 and 65, 8 people between 65 and 70, and 8 people between 70 and 75. Now obviously that's an approximation because they could all be over here or they could all be over there, but we're just going to use that. So we want to know who was over 70. So in this case, over 70 were 8. These were all less than 70, we're going to say. So out of this group, I'm going to call 8 of them. So we're going to say 8 plus 9 plus 4 are the proportion of people that were speeding. So let's do 8 plus 9 plus 4 presents us with 21 people out of a total of 50 cars. Sorry, I'm talking people, but obviously it's cars. And it's that proportion out of the total. So 21 over 50 multiplied by 8,400. And that tells us, I made a mistake somewhere. Oh, I forgot to put my multiplication in. There you are. So we ended up with 3,528. Now that's how many cars were speeding. The question was not how many, but what amount of money did they raise. So every car that speeds gets a fine of 60. So £60 multiplied by 3,528. So it comes out at £211,000 680. So 211,680. Quite a lot of money, but that was quite a lot of cars actually. I'm just having a little thinking, well, that's quite a high proportion, but obviously people are speeding in this case. Part B. Mia says that 4% of the vehicles on the road travel at 40 miles per hour or less. Explain why she might be wrong. Well, 40 miles or less. So she says, okay, let's take those 2 cars because they are 40 miles or less. And what proportion was that? So 2 out of 50 cars to find out the percentage. 2 divided by 50 times by 100, and she comes out and it looks like she's correct. Okay, so far I think, oh, it's fine, but it says explain why she might be wrong. Now this is 4% for only 50 cars in the sample, but this might not, or very likely not be representative of the whole. What do I mean by that? Well, it could be that this was measured in the morning and people were calm, they were awake, and then if you actually looked later on in the day when people are tired, they're rushing, they want to get home, etc. Or it might be the other way around. This was measured at a time like at the weekend when perhaps people were kind of quite relaxed, or the other way around, perhaps at the weekend people will be more relaxed and you get more people that will be driving slower. Or it depends where. It could be that it's in a different part. So the whole thing is you just don't know if the pattern is representative. When they measure this, is this typical of what happens all the time? And the most likely is no. Okay, we're on to question 18, and question 18 has a formula, and they tell us that f is equal to x divided by y, and they tell us that x increases by 25% and y decreases by 20%. Work out the percentage increase in f. Now if you remember percentage increase, if you want to do that, you need to have your final value minus your original value divided by your original value, and you multiply that by 100, and that will give you a percentage increase. So what we want to do is want to find out what the final value, because we know the original value is what we're starting off with, but we want to find what happens after this has occurred. So we have f. I apologize because I've used f and I just realized f could be ambiguous here, because here I mean f in this calculation. So I'm going to change that and perhaps say original, what shall we call it, after, I don't know. So anyway, here we have the formula, and it tells us that x increases by 25%. So in other words, it was 100, but now it's 125% for x. Okay, and y decreases. So if you take 20% away, you're left with 80%. So f after is going to be 125 divided by 80, 125 divided by 80, and that's what the value is for f after, 1.5625. Okay, so if we use this formula or this thing to work out a percentage increase, we'll say that after it was 1.5625, and before this original value, well, originally it would be 100 divided by 100, because before we did anything like this, which would come out to 1, and divide by 1, and at the end times by 100. When you do that, you can do it all in one step in the calculator. 1.5625, take away 1, divide by 1, and multiply by 100, and you'll end up with 56.25%. Now they've already put the percentage sign there. Question 19, we're on to some algebra, and it says factorize fully this expression. You notice common terms or common factors are multiples of 3, 9 is a multiple of 3, 6 is a multiple of 3, and the a's. So if we're going to put a bracket in, we can take a multiple of 3 out and we can take an a out. So if I do that, I'm going to be left with a 3 inside the bracket and an a, because 3a times 3a would be 3a squared. Subtract, and 3 times 2 would be 6, and I don't need an a there because there's an a there. So let's rewrite it down here because that looks good. 3a, open brackets, 3a, take away 2. And that's our answer for part A. Part B says solve and they have here an equation, and we're going to solve it. We're going to find out what x makes that equal 0. Now you can use the quadratic formula that's on the formula sheet, okay, but I'm just going to factorize it because it's good practice. So what I'm going to say is what brackets what is that as 2 brackets if I factorize? Now there's clearly going to be an x, because x times x would give me the x squared. And we now want to think of 2 numbers, okay, I'm looking for 2 numbers that when I add them, they give me a negative 12, and those same 2 numbers, when I multiply them together, I get a positive 20. So you have to have a little think about what numbers could happen, but 20 you could do like 1 times 20, but 1 plus 20 wouldn't give you that. You could do something like 2 times 10. Oh, that's looking hopeful, isn't it? Because that looks like I could add a 2 and a 10 together. So I'm going to try a 2 and a 10 and a 2 and a 10. Now this is positive and this one's negative, so if I add 2 negative numbers I'll get more negatives, and if I multiply 2 negative numbers I get positive. So it looks like I have here a negative 2 and a negative 10. So if I expand that, I'm going to get a negative 2 plus a negative 10 to get negative 12, and minus 2 times minus 5 will give me a positive 20. Okay, so I factorize it, and when I solve that I now need to make this bracket equal 0. So that how can I make that 0? Well, if x equals 2, 2 take away 2 is 0. So one of the possible answers would be x is equal to 2. And the other answer would be over here. If you say, what can I put in there? Well, x, 10 take away 10 would be 0, so x equals 10. So those are the 2 answers by factorizing. But you could have used the quadratic formula, substituted it in, put it in your calculator, and you'll get the 2 values like I did. Okay? That's the beautiful thing about maths. There's different ways of doing it. As long as you get to the same point and you show your workings, you'll get the marks. Question 20 presents us with an equation of a circle, x squared plus y squared equals 4, and they're asking what is the length of the radius, and that's where you remember that this bit here is your radius squared. So something, in other words, radius squared equals 4, so you are going to square root it, and square root of 4 is 2, so our answer is going to be 2. We ignore any negative answers because radius is going to be a positive value. It says here, Luke has a rectangular garden. The length is 40 meters by 25 meters. Both measurements are given to the nearest meter. Mara also has a garden, and the area is 970 meters squared to the nearest 10 meters squared. Mara thinks her garden has a bigger area. Is she correct? Tick a box, but you must show your workings. So we're going to look at what Luke has. Okay, and in Luke's case he has 40 meters, and if it's to the nearest meter, we're going to divide it by 2. In other words, we're going to have half a meter plus and half a meter minus. So the length could have, if I take away half a meter, the length of his garden could be 39.5 meters long, and it could be less or anything up to, but not the same as 40.5. okay, because we're not allowed to have equal, because obviously it would then round up. And here we do the same thing, 25 take away 0.5 would end up with 24.5, and that's the width, and 25 plus 0.5 would end up with 25.5, but again it's not equal because it can't be, otherwise it would round upwards. Okay, so the smallest value of the length would be this, and the largest value would be something just slightly smaller than that, something like 40.49999, etc. Okay, now in her case her area is to the nearest 10 meters, so 10 divided by 2 means it's going to be plus or minus 5 meters. So her area, I haven't worked out Luke's yet, but if I work out her area for Mara, her area, sorry about this, I've got to give some space. Her area of her garden is going to be 970 plus another 5, but just slightly less than that, or the same as or bigger than 965. Okay, so her area is between these two values, meters squared. So we're going to work out Luke's, and to do Luke's we're going to work out the biggest and the smallest values, and the area is base times height or length times width, so we're going to do 39.5 times 24.5 for the smallest value of Luke's, and Luke's smallest value of his area is going to be 967.75 for his area, and it can go up to 40.5 times 25.5, which comes out to 1032.75. Now obviously can't be that value, but be slightly less than that, and the same here, slightly less than that one. So the question is, knowing that, okay, knowing these values, her garden can be anywhere between this and his garden can be anywhere between that, and we want to know, is hers, because she says she thinks hers is bigger, can we actually say that? Well, at the moment we can't actually tell. How do I know that? Well, because here his smallest value is bigger than her smallest value, so it could be that his is bigger, okay, but it could be that his smallest value is actually smaller than her bigger value. So again, it's possible that his garden's smaller, or the other way around. It's possible, if you compare this one with that one there, that his is bigger. It's possible to either be bigger or smaller, because we don't actually know for definite, because things have been rounded. Okay, now sometimes we could, if both his values were bigger than hers, we could say his is bigger, or if both her values were bigger than his, then we could say hers is bigger. But in this case we can't, so we just say we can't tell. On to question 22. Question 22 presents us with an identity, and they tell us on the left hand side we have this completing the square, and on the right hand side we have a quadratic, basically a quadratic expression. It says work out the values of a and b. So in this case what we're going to do is we're going to expand the bracket and collect the values and then compare to see what a and b are. So if I expand this bracket here, if you remember, that tells me that what I actually have is x plus a squared, which means x plus a, and if I square that I'm going to end up with x times x squared, a times x plus another a times x, so we're going to have 2ax, and a times a is going to have an a squared. Okay, so when I now do this, I'm going to write the left hand side, and so the left hand side is x squared plus 2ax plus a squared, take away 7, and that is identical to x squared plus 10x plus b. And we want to find out what is a and what is b. And to do that we're going to compare and balance it out. So if we look here, x squared matches x squared there, so I'm not going to focus on x squares, they're done. Okay, so I'm just going to tick those match. I will now look at the term that has the x. Okay, by that I mean that term there. There's no x here, there's no x there, so I'm going to ignore those. And again here there's no x there, so I'm just going to focus on this one there. And so looking at that, this has to be the same as this side. So here I have 2a is the same as 10. Okay, so in other words 2a is the same as 10, because if 2ax here equals 10x over there, then they have to be the same. So in other words, 2 lots of a is 10, which tells me that a is worth 5, because 2 times 5 is 10. Okay, right, we will now compare the terms that have no x, which is what I'm circling here or highlighting in red. Okay, and when I do that, it tells me that a squared minus 7 is the same as b. Now we know what a is because a is 5, so if I do 5 times 5, 25, I'm going to end up on this side ending up with 25 take away 7, and if I do 25 take away 7 I end up with 18, and that's what's happened on this side. But they tell me that's the same as what's on this side, which is b. So in other words, 18 is the same as B. So B is 18. Sorry about that, I've just written answers there. Okay, brilliant. Good, that's rather nice. Oh, we're on to the last page, not bad. So, question 23. The equation of a curve is y equals, open brackets, x plus 3, close brackets, squared, plus 5. That's in a completing the square format. Circle the coordinates of the turning point. And so this is where you remember that basically the x coordinate is what makes this bit 0. So what would be 0 would be a minus 3 here, because 3 take away 3 would be 0. So we're looking for a minus 3 for the x value, which means that that's no good. That's no good. So it's between one of these, and that's looking there. There we have minus 3. And the y value would be 5. So that's our answer there. Okay. Question 24. We have angle ABC, sorry, triangle ABC. P is a point such that A to P is the same as P to C, marked by these lines. And it's also the same as B to C. So these three lines are the same length. Angle BAC, going from BAC, is called X, and I've marked it there as X. It's not drawn accurately, and it's asking us to prove that the angle ABC is 2x. So they want us to find angle ABC. So they want to prove that that one there is worth 2x. Okay, that's what they're telling us to do. So what are we going to do? Well, first of all, we will identify that since these two sides are the same, triangle APC is isosceles. Okay, so we're going to say that triangle APC is isosceles. Okay, and why is that? Why is that matter? Well, if it's isosceles, then we know that these two angles will be the same. Yeah. So we can say so angle PCA. Okay, so angle PCA is the same as angle PAC, and we call that X. Okay, so we've just said that that angle there is the same as that angle there. Right. How does that help? Well, we can work this one out. How can I work that one out? Well, inside the triangle, all the angles add up to 180. If this one's X and that one's X, this one here will be 180 minus X, or minus 2X. Okay, so we can now say that angle APC is 180, take away 2x. Okay, so this one here is 180, take away 2x. So what do? We now notice this is a straight line. If that's a straight line, then we can work out this side, because that side is going to be 180. Take away that angle. So now we can say the angle BPC is equal to 180. Take away what we had already, was 180. Take away 2x. 180 take away 180 disappears, and taking away a negative disappears, and so we're just left with 2x. So this side here is called 2x. Now we know that triangle BPC is isosceles. How do I know that? Because these two things are the same, so that's an isosceles. And so that tells us that the angle BPC equals angle BBC. Okay, that angle there equals that angle there. So BPC equals PBC. And we know that's then going to equal 2x. So we proved it, which is what they wanted to know. Okay. Then they tell us that you're also given that AB equals AC. So AB equals AC. work out the value of x. Now, if that equals that, that means it's isosceles, which means that that angle there is 2x. Yeah, will also equal this angle there, which will be 2x. Okay, so if we just focus on the big triangle, the angles add up to 180. Okay, in the big triangle we have x plus 2x plus 2x, because it's isosceles. Okay, so 2x plus 2x is 4x plus x is 5x. So 5 lots of x equals 180. So 180 divided by 5 tells us that x equals 36. So in this case I can write down here x is equal to 36 degrees. Let me put the degrees down there. Okay, good. Okie dokie, we're on to the last question. What do we have? Question 25. A small toy is made by joining a small cone and a... Okay, here we have a cone and a hemisphere. Hemisphere is half a circle, of a sphere, sorry. The radius is 6 centimeters, and they give us the full length of this is 20 centimeters. The volume of the cone is given by that formula, where h is the height and r is the radius, and the volume of the sphere is given by this formula, where r is the radius. Show that the volume of the toy is 312 pi centimeters cubed. So this toy is made of 2 bits put together, so we're going to work out the volume of the 2 bits and then stick it together. So what do we need to know? We need to know for the volume of the cone, the volume is 1/3 times pi times radius, but they told us radius is 6, so we can just write that in there, squared, times the height. So we have to work out now. The height of the cone is that bit there. Yeah. They've given us the full bit. They've given us all of it. They've given us 20 from top to the bottom. So what I need to do is I need to know what this bit is. But if this is a sphere and the radius is 6, then this here will be 6. So 20 take away this 6 will give us the bit that we want, and 20 take away 6 will leave me with that bit there, and 20 take away 6 is 14. Yeah, 20 take away 6 is 14. So when I come to do this, I'm going to say the height of the cone is 14. Now notice they've left pi in the answer here, so I'm going to leave pi and I'll just calculate the numbers. So we're going to do 6 squared times 14 divided by 3. Okay, so we're going to end up with 168 pi centimeters cubed. Now we're going to work out the hemisphere. Okay, hemisphere, and hemisphere is the sphere, which is 4/3 times pi times radius, and the radius is 6 cubed, but that's for a full one, so then after that I'm going to divide it by 2. Okay, so whatever the answer comes out to, I'm then going to divide by 2, because we only have half of a sphere. So we have 4/3 times 6 to the power of 3 divided by 2, which comes out to 144 lots of pi. Notice again I didn't calculate the pi. That's centimeters cubed. And the final volume is going to be the two things added together, 168 pi plus 144 pi. So 168 plus 144 comes out to 312 pi centimeters cubed, just like they wanted us to show. Then it tells us a larger version of the toy is made, and this larger version has dimensions that are twice the size of a small toy. So everything's doubled. And they also tell us the mass is 1.5 kilograms. The toy is made from foam. Work out the density of foam. Give your answer in grams per cubic centimeter. Okay. So once again, we get a bit of a hint here, because that's in grams and this one's in kilograms. So let's change that straight away into grams by multiplying by 1,000. And if you multiply it by 1,000, you end up with 1,500 grams. So we've changed it to grams. Now the cubic centimeters, we're already in cubic centimeters, we already have that volume, but that was for the small toy, and now we have something that is twice the size. But remember, with volume, when you have volume, you have basically 3 dimensions, yes? So if each side is twice the size, you're going to have twice the size for the length, twice the size for the width, and twice the size for the height. So in other words, you're going to be 8 times bigger. Yeah? Length, width, and height. So 2 times 2 times 2, 8. 2 times 2 times 2, just in case you're not sure, 8. So 8 times. So our volume was 312 pi, but we now have 8 times that volume. Okay, so 312 times 8 comes out to 2,496 pi. Okay, but they actually want our answer. They haven't specified, but we presume they want it not in terms of pi. So if we times that by pi in our final answer to do it, okay? Now, the question is density. When you work out density, density is mass divided by volume, but you can see that here. Mass divided by volume, here mass divided by volume. So what's our mass? Our mass was 1,500 grams divided by volume, and the volume was 2,496. Lots of pi. Made a mistake there. Let's just change that. Meant to be a 6. Okay. So let's put it in a calculator. 1,500 divided by 2,496 pi. Let's put the pi in there. Okay. And so it comes out to 0.1912919, etc. What level of accuracy? A little bit unclear. Perhaps 3 significant figures, so 0.191. That's probably close enough for what they wanted. Okay, they haven't specified, but we showed the workings, so we can get hopefully all the marks for that. Anyway, I hope that's useful. I hope you have a nice time. Bye until next time.